This is compound interest when we are compounding non-yearly. So as we've learnt with compound interest, we calculate the interest at certain time periods and that gets added on to the amount in the account, and then next compounding period, next time the interest is calculated, it's calculated on the total amount in the account, the interest and the principal. So far we've learned this compounding interest or calculating it once every year, but a lot of bank accounts and a lot of mortgages compound it or calculate it more often. So they might say compounding monthly, as in this question that we're going to do here, which means they calculate the amount of interest owing every month instead of every year. Now, because they tell us in this question how many years it's been invested for and what the percentage interest rate is in years, we're going to have to work this out. How many months is this and how much is your interest rate per month? So the question, Courtney invests $50,000 in an account that earns interest at 4.5% per annum, compounding monthly. How much is in her account after 3.5 years? In our formula, the interest rate is the rate per time period, and N is the number of time periods. And our time period in this is months, because we're compounding monthly. So there's a pair of calculations that we'll have to do to work out what is 4.5% per annum per month and how much is 3.5 years in months. So we'll need to know how many months there are in a year, 12 months per year. And we'll just do some extra little calculations. So we're still going to be using this formula, we're still going to be writing down these things. They want to know how much is in her account. That's the amount, that's the thing we're finding. The principal is $50,000. Now, the rate, the interest rate per time period, it was 4.5% per annum. So per annum is 12 months. So we're going to divide our interest rate by 12 to get the rate for 1 month. So if we want to grab the calculator, 4.5 divided by 12, 0.375% per month. So that's still a percentage. And the number of time periods, I've got 3.5 years, and there's 12 months in every year, so I'm going to times by 12. That's 42 months. Now what you'll notice is that to get the interest rate from years into months, I divided by 12. To get the number of time periods from years to months, I multiplied by 12. So there's going to be this pair of divide and multiply to get this into months and this into months. And so you're going to be almost always doing divide by 12 and times by 12. The only exception would be if they told you this interest rate in a percentage per month, which is this. Because the time period, the units of months and months have to match up for the interest rate and the number of time periods. So now we have all the information we need. We have the option of using the formula or using our graphics calculator. We'll use the formula for this one. We write the formula, substitute in our values, and from there you can just type that straight into your graphics calculator. 50,000 times, use your brackets, 1 plus 0.375 divided by 100, use your power key, to the power of 42. And there's your amount in the account, which would round to 2 decimal places. Because it was a word question, we'd give a word answer. There was $58,511.80 in the account. We take the answer from the question, how much is in her account after 3.5 years? So we say after 3.5 years. So that's how that one's worked out. So just a second question. Rodney invests $35,000 at 3.8% per annum compounded quarterly. How much interest has he earned after 14 years? We always set it up APRN. Now they're asking how much interest. So you remember that interest is the amount minus the principal. So we'll have to be finding the amount and then we'll subtract the principal. The principal was $35,000. Now the interest rate is given per annum, but we're compounding quarterly. Now a quarter is 3 months, so there's 4 quarters in a year, quite reasonably obviously. So it's this much per annum. It'll be a smaller amount per quarter, so it will be 3.8 divided by 4. And the number of quarters in a year is 4, so there's 14 years. This will be 14 times 4. So see that match pair of divide by 4 times by 4, and 4 is the number of quarters in a year. Now you'll remember we can use our graphics calculator for the compound interest formula. All we have to do, and we don't need to show this in our working, is rearrange the formula so we're subtracting the principal times 1 plus the rate on 100 to the power of n. That it will equal 0 because we've subtracted all this from both sides. So on your graphics calculators, whoops, trying to fit that in, we go to Math, use the up button to get to the solver. Now for this version we put 0 in one box and the other half of the equation in the other one. On the old ones we'd just type in this half of the equation. So 0 in one box. We use the alpha keys to get A, the amount, minus the principal, times, or just outside the brackets, 1 plus R, remember these are in alphabetical order which makes them easier to find, divided by 100, close your brackets, to the power of n. On your older calculators this will just show your little arrow key for power and n. Hit enter and it will bring you up our options here. 0 in the amount because that's what we're finding. We enter 35,000 there. Remember that this will do the calculations for you. 3.8 divided by 4. So you'd stop and write those down when you got them. And 14 times 4 is 56. So then we're solving for the amount. We move back up to the amount alpha and solve. So $59,432.25. That's the amount in the account. We want how much interest he's earned. So we'd do our working. Interest equals amount minus principal. Sorry, I'm running out of space here. 59,432.25 minus 35,000. Now this is a lot of interest, but because compound interest really does earn a lot of money over that sort of time. So subtracting, and you can always just hop to the end of this one, so you've already got that typed in. Take away 35,000, 24,000, 24432.25, and a word answer as well. He had earned this amount of interest after 14 years. Sorry, I'm getting a little messy there. So, as long as you know how many months are in a year, how many quarters are in a year, how many weeks are in a year, that's you working for investing when you're compounding more often than 1 year.